I'm going to be doing problem number 3. The first thing we need to do is decide whether or not this is a parabola, a hyperbola, or an ellipse. Now, we can tell this is a parabola, a hyperbola, because both x and y variables are being squared. Also, we know that a times c is less than 0. It's a hyperbola. This is our a, and if we would rearrange this, this would be our a, b, c, and a times c is a negative, so we know that this is in fact a hyperbola. The next thing we need to do is take this and put it into standard form. So first I'm going to rewrite this. And also going to move over this constant to the other side. Next thing we're going to do is complete the square for the x's and the y's. Factor out that negative. X squared plus 8x. Take half it. 4 square it. 16. Now we're going to do the same thing over here and take out 4 y squared minus 2y because we factored out 4. Half it. Negative 1 square it plus 1. Now, whatever we do to one side, we must do to the other. We added 16, but we factored out this negative, so really we subtracted 16. On this side, same thing, we have a 1 in here, but we have a 4 being multiplied into it, so we're adding 4. So now we can rewrite this. Add plus 4. (48 minus 16 is 32, plus 4 is 36. Now we need to divide this 36 over. Now, this can reduce, so we're going to reduce that, and we're also going to put the x on this side because it's the negative. So we can have y minus 1 squared over 9, because 436 reduces to 9th, minus negative, make that our x, plus 4 squared 36 equals 1. Now this, this is our standard form. Now, the next thing we need to do is state our center. Can I still see? Okay. Now our center is always H and K. Now because this is our h and this is our k, but normally it's x minus 4. And since this is a positive, we know that it was minus 4. So our h is minus 4 and our k is negative 1. Oh, no, just okay. Okay, now the next thing we need to do is determine the direction of the hyperbola. We know that because our y variable is positive and our x variable is the negative, that this is going to be a vertical hyperbola. Okay. Hyperbola, which will look like this. Okay, it'll look something like that. Our next step is to graph everything we have so far. And our fundamental rectangle. Okay. Our our k and y are always over b. So that would be b equals root 9 equals 3 and a equals root 36 equals 6. Okay, we're gonna graph our center. Put our center, negative 4, 1, center, negative 4, 1. Okay. And we can put, whoa. We're missing our transverse axis. Our transverse axis is just going to be the same as our x value of the center because we have a vertical parabola. So I'm going to put that there. Transverse axis of x equals negative 4. Okay, now to get our fundamental rectangle is 2a minus b. So we're going to take our a is 6, and we're going to go out to the right 6, go down 3 because it's our b. 1, 2, 3, 1, 2, 3, 4, 5, 6. 1, 2, 3 over 6. 1, 2, 3, 4, 5, 6. 3. that is our fundamental rectangle. So now I think we have everything so far. We'll go back to this. Next is to find our vertices. Now to find our vertices, we know because this is hyperbola. Oh wait, never mind. We're gonna go up from our center, 3, 1, that's not 1, 2, 3, and put a point there, and then 1, 2, 3 down. Because the distance from our center to our vertices is B. So that is gonna be our vertex 1 at -4, 4, and this one was gonna be our vertex number 2 at -4, -2. Okay. Now let's just write that. Just make a note of that. 4 and -4, -2. Okay. Next, we're gonna find our focal length. Which is also known as our C. Now our focal length can be found by taking the square root of a squared plus b squared, which is square root, our a is 6 plus 3 square root. C, 6 squared is 36, 3 squared is 9, C square root of 45. Now, that doesn't do us much good, so we're going to break up the radical. 9 times 5. Now we know we can take the square root of 9 to give us 3 root 5. 3 root 5 is our focal length. Plus or minus because of the square root, we don't know for sure. Now we're going to find our foci. Foci 1, foci 2. We know we have 2 foci because this is plus or minus. And we're going to add that to our y value because this is hyperbola, our hyperbola looks something like that, and we know that our foci have to be inside the graph. It's included in the graph. Should be -4, 1 plus 3 root 5, and then -4, 1 minus 3 root 5, which is 7.7. It's approximately -5.7. Next is our asymptotes. Y'all still see? Oh. Oh. Okay, let me just fix that real quick. That's much better. Okay. Now, still see? Okay. Now let's find our 2 asymptotes. Now, we can find our asymptotes by using y equals mx plus b our asymptotes are going to go, we're going to make a diagonal line with our asymptotes from this corner of our fundamental rectangle to this corner and this side to this side, or this corner to this corner. Now, we can use plus or minus b over a as our m. And our b is 3 and our a is 6. So it's 3, 6. Plus or minus, can't forget that, it's very important. Plus or minus half. Okay, so we're going to have two asymptotes. So asymptote number 1 is going to go, we're going to put our center in. We're going to use that. Our y value of the center is 1. 1 equals half. Our x is -4 plus b to find b. And then 1 equals -1/2, -4, our x value plus b. We're just doing this to find our b values. Excuse me. Okay, half of -4 is -2. -2 plus b, we're going to add this 2 over to get 3. b equals 3. Same thing over here. -1/2 times -4 is just 2. 1 equals plus b. Subtract this 2 over to get -1. So we will have our b over here is equal to -1. Now we can put these back in here to get our asymptote 1 equals half x plus 3. And our asymptote 2 is going to be -1/2 x minus 1. Now, we're going to go ahead and put these on our graph. There it is. No. We're going to use orange for our asymptotes. Going to go from this corner to this corner. Asymptotes don't stop, they keep going until we reach the end of our graph, which is fairly soon. Now this is going to be our -1/2 x minus 1 because our y-intercept is -1 right there. So we're going to label this y, this is our second, equals -1/2 x minus 1. Okay, now we're going to graph the other one from this corner to this corner. Probably good enough, you get the picture. Put our arrows there to show that it goes on forever. And we're gonna label this one, this is our asymptote number 1 equals 1/2 x plus 3. We know this is 3 because it intersects the y-axis at +3. Now, we need to find our I step is to graph everything we've covered so far, but we've been doing that as we go along, so we're all caught up. We're all good. did. Our J step is to find our x-intercepts and our y-intercepts. X-intercepts and our y-intercepts. Now, looking at our graph, we know this vertex point is here and this one's here. So we know we're not going to cross this x-axis. So we already know we don't have any x-intercepts. Our y-intercepts, however, we can use, we'll go back to our standard form while letting x be 0. Whoop, that's supposed to be a 9. Minus x is going to be 0. Now we're going to multiply both sides by 36 to get rid of the denominators. 36 divided by 9 is 4, so we're left with 4 y minus 1 squared minus, well, 0 plus 4 is 4. 4 squared is 16 equals 36 now. We're going to add this 16 over. It's 4 y minus 1 squared equals 52. We're going to divide this 4 over. 52 divided by 4 is 13, I think. 2, 26, 52, yes. Y minus 1, 2 equals 13. Now we need a square root. Y minus 1 equals square root of 13. Our y equals plus or minus, because we never know. Y equals 1 plus or minus square root of 13. So we have 2 y-intercepts. And that is going to be, use smaller pens so this is easier to see. Our first y-intercept is going to be 0, 1 plus 13. Our other one is going to be 0, 1 minus 13, which is approximately, this one is approximately 4.6, and this one negative 2.6. Okay, now we can graph our x-intercepts. Okay, I mean not our x-intercepts, our y-intercepts. So we have 0 up to 4.6, which is about right there. This is my y-intercept of 0, 1 plus root 13, negative. Now we're about negative 2.6, so we're gonna go down to negative 2.7, about right there, I guess. This is our y-intercept of 0, 1 minus root 13. Okay. Now I will just, okay, it's gonna look something like this. Trying to make this look pretty. Going through all my points and information, but that's okay. Continues on forever, getting closer and closer to that asymptote. And on this side, we get the same thing. We'll see this our line get closer and closer to this asymptote, but it will never fully touch it. And that's our graph for number 3.